right, pause for a second, and she needs your attention. Come on. You get to go up front.
What I did was I started off from the beginning. It was 1 times 2 is 2. And I kept going until I
So,
reached.
where's your first number? Point. Because it kind of looks, okay. So, stand on this side. And then, can y'all see that? Yes? Yes? Okay. So, talk about that one. Go ahead.
So I did 1 times 2, which I got 2. Did 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 64 times, no, 32 times 2, 64. 64 times 2, 128. 128 times 2, 256.
Okay, stop for just a second. I want you to take the marker and I want you to go put at least that first row up there. Your calculations, okay? Just what you just said, okay? Here. Yes, I do want you to come up. All right. Go ahead.
So I took the dollar that they said that you was going to get for the first year, and I'll multiply it by 2. And I'll keep pulling the number out and multiply by 2 each year until I got to, this was the wrong number, I think. So
Okay.
it's right here. So I put 20, that was 21. This is the 20.
Okay.
So I got
So your answer is how much?
52,428.
Okay, so change your comma. Okay. Change your comma. Do Simone and Kiera have the same method for option 2? Yes? Yes? Okay. Do you think that there's another way that we might have been able to find that number after we look at the pattern? That's what I want you to be looking for. Or that's what I'd like for you to look for. So if that is indeed truly the right number, what we're trying to figure out is there another pattern or something that you know about that would help you find this a lot faster? Okay, so Darrell right now is thinking you'd have to make an equation. Because if I asked you how much you would have after 100 years, like let's say you left money behind for somebody, then you wouldn't want to sit here and do this 100 different times, would you? No. Okay? So I want you to be thinking about what it is that they have in common. So say this number for me again so that you can tell me how much you think we have after 20 years.
524,288.
Very good. Dollars. $524,288. Okay? So I want the both of you to go up. And while we're doing that, so Taquan, you go. Good job, Kieran. Thank you. And thank you, Simone. Because I'm going to ask a question because yours wasn't on the paper and hers is, so I'm going to put them back up there in just a second. Okay? And this is going to have to do, remember what you're supposed to be thinking. Something that they possibly have in common that you might be able to use to write you an equation. Okay? So you want to talk to me about what you think you did? Go ahead. Speak up.
Well, the first year I started off with 1, and I timed by 2, and I just kept going by 2, by 2, by 2, every time until I got to 20.
Okay. So, do you notice something about his paper, though?
He made a table.
He made a what?
A table.
He made a table. He made a table. So sometimes when we have a table, it would, I guess, infer that we have some different types of values that go with that equation that Darrell is talking about, because in equations, what variables do we usually have? Come on. What? Come on. I heard you. What kind of variables do we have in equations? X's and Y's maybe? So we need to be thinking about some type of equation that we can make for this particular problem, right? Using what they have in common, and now what we have is a table that we might be able to do that with. So in this first table, or in this first column, what would this represent in words? What does this represent? Nah, that's not a word. X is a variable. So it could be variable X, but what would X still represent? Words. Come on. The what?
The year.
The year. Is that, look at it, come on. So this is the what? First year. This is going to be the, all right, and if this is indeed X, if it truly is X, then that means that X is going to have to be, how would I define that? X is going to be, what about the years? Not just years.
The number of years.
Number of years, amount of years, the year that I'm on. Do you understand what I'm saying? Yes? So right now, we are doing this. And that is when we tell what the variable actually represents in words. This is one of the things that you did not like about your word problems. But sometimes if you define a variable and you can tell what it is that you're trying to find or what you have in words, it makes a lot more sense. Are we working with years here? Yes or no? Yes. So one of the things that's ever changing, are we still on the same year every year when we're looking at the money? No, the years are doing what?
Going up.
They're changing and they are going up. They are increasing. So X is increasing. Do you have that? Yes? And what did we say that that would represent again?
The number of years.
Number of years. Are we okay with that? So let's look back at his table again. And on his table, if this column would be X, then this one is probably going to be what? Y, possibly. Because as X changes, then it's going to affect how Y changes. That's good. How Y changes. X is going up, so what else is, well, what is Y doing? Going up. Do you understand that? Yes? Okay. So what, if we wanted to define Y, what would we define it with? An amount?
The amount of money.
The amount of money. The amount of money. Got it? So this is the number of years. Of course, in years. Because this is my label. This is my money.
The amount.
How do I label it though?
The amount money double.
Yeah, but I can say money, but I guess what I'm saying to you is, you know, when you measure length, you might say centimeters, you might say inches. So when you do money, what do you label it with?
Cash.
Yeah, you don't say, when you go to the register, you do not say, the person doesn't say, can I get five cash?
The amount.
They don't say,
They used to.
no, they don't say 5 cash. They say 5 what?
Dollars.
So what is your unit on your money? Dollars. Do you understand that? Do you understand what I just asked you? So you need all of this. You need all of this. So then if I'm getting ready to make me a graph, sketch it, because that's really sloppy, right? Which axis is this one?
The money.
Wow.
Oh,
This one is Y, but I still have to define what it is.
Oh,
The
money.
The money, this is my money.
Money and dollars.
Money in dollars. Dollar bills. Okay? And this axis is which one? Which axis? Now be careful. Which one? X. And how did I define that one?
Number of years.
Number of years. And of course that's in years. That can happen sometimes. Okay? Maybe. But this time not. Because really we're not talking about which year. So leap year doesn't matter. We're talking about which year, I guess the amount of years that have gone by. Does that make sense? So do y'all understand his question? He's asking about a leap year, which is perfectly valid. But it doesn't matter if we add in a leap year because we just have another year that we've added on. So the number of years passed that I've been collecting this month. All right, we good? Because I want to kind of close this out. We okay? You did good. You did good. You did good. You did good. Do you understand what's going on? How many people chose option 1? Toya, you all right? You good now? Yes? A little bit better? And you found your mistake? Okay. The benefits, in some ways, are that the students get to see that they know more than what they think they know. I've always found that to be one of my favorites, especially when I can connect their idea to someone else's idea. because a lot of times in math, they don't typically like math, especially when they start moving up into upper level math or even dealing with functions. No matter how smart a kid may be, functions tends not to be their favorite topic. And so with this idea, if you can connect one person's thought process to another and have them talk about it, then it makes for a happier class in a sense, because they feel like they're part of the lesson instead of someone telling them to do something. And a lot of times the overshadowing of it makes it seem like they're the ones that are running class. It also makes them, I guess it gives them the ownership that they're looking for, and they're a lot more satisfied when they walk out of the room because it was their idea. It wasn't the teacher's idea. It didn't come out of a book, and they can see how it played out. I guess the hard part, or the challenge more so, is that you never know which direction they're going to go in, and because you're looking to connect an idea to another one, you have to think fast. And a lot of that thinking fast comes from just wondering, well, what would they have said? So the planning behind it is very difficult because you don't really know which way they're going to go. And because you want to make every child feel like they contributed, you really have to think about your own sense of mathematics. You have to dig all the way back down to elementary school and then think all the way back up to the student who thinks a lot faster than another and be able to connect those all the way through. And that's really, really hard sometimes. I guess in the idea of that challenge, though, because you want to give them ownership, a lot of times I throw it back at them. If I can't think fast enough, I'll throw it back at them to see if someone in the room can help me figure out, well, how can person B's problem or the way that they solved it or what they said connect back to person A or person C that might have said something. And while they're doing that and thinking, then I'm thinking too, and it gives me a little bit of breather room to connect everybody back together, and then everyone's happy. So it works pretty well, but it does become very, very hard.